So what we're going to look at here today is doing some inequalities, solving inequalities. What you'll find a lot of the stuff is the same thing we did with equations. So we'll just talk about a couple of the differences. But the steps we're going to go through for the most part are going to be the same as if you were solving an equation. Okay. So an inequality we know is a statement with greater than, less than, greater than, equal to, less than, equal to. Okay, so something as simple as y is greater than 4, right? So we're talking about all of the numbers that are larger than 4, right? If we have that equal to with it, right, that includes 4. Y is greater than or equal to 4, right? That's 4 and anything larger than that. So inequalities are a number sentence that has any of one of those signs in it. So when we want to solve an inequality, let's say we had 2n plus 4 is less than 8, for example, we're going to go through the same steps as we would as a two-step equation. Okay, so I'm going to draw my line. Okay, I'm going to zero out the plus 4 by subtracting 4. Always start with your addition or subtraction first, so that zeroes that out. I've got a 2n then equals 4. Again, we want to rewrite. Oops, see, and I messed it up already. Let's try that again. 2n is less than 4. There we go. So you can see a common error, and I do it too when I tend to work through these, is getting a little bit fast and sloppy and not dropping that sign down. Okay, so I want to make sure we keep that sign uniform as we work throughout these. So I'm at 2n is less than 4. Again, undo your multiplication with division, and I get n is less than 2. Okay, so any number less than 2 in this particular case is going to be a solution, right? Now that's an infinite amount of numbers. So what we're going to do with our inequalities is we're going to graph the solutions. Okay, kind of an introduction to this as you progress through math, through algebra, advanced algebra. You'll get a little bit more complex in terms of graphing this and using different notations, but right now it's just kind of a basic introduction in how we graph an inequality. So what we're going to do is we're going to graph that on a number line. Okay. So if I have a number line here, we'll make that 0. So I've got my positive integers and my negative integers. Okay. So the first thing we need to show on the graph is whether or not we include 2, right? N is less than 2. Well, 2 is not less than 2, so 2 is not a solution to this. Okay. So to indicate that 2 is not a solution, we're gonna use an open circle. All right. So if I'm using less than or I'm using greater than, we use an open circle. An open circle just tells the person looking at it that 2 is not a solution. It's the boundary of your solutions, but we don't include it. Okay. It's like if there's a hole, right, 2 would fall through that hole. Okay. And then we want numbers less than 2. Okay. So then we're looking at that way, right? If you're not sure which way the line goes, just pick a number and try it, right? 0. Is 0 less than 2? Well, yeah, it is. So the line would point towards 0. Okay. Now let's look at a different inequality. Let's say that I'll keep the numbers the same, but I'm going to make it less than or equal to 2. Okay. So now 2 is a solution. 2 is less than or equal to 2. So when I have those symbols, I'm going to fill in my circle. It's like I'm putting a cover on the hole. The number doesn't fall through anymore. It's part of the solution. Okay. So I would come up here and I would put a closed dot and fill in the hole. Okay, to indicate again that that is a solution to the inequality, and I want numbers less than 2. So again, my arrow would go to the left. Okay, so that would be n is less than or equal to 2. Now, there's one unique rule we have for inequalities, and that I'll show you right now. So let's say I had an inequality: negative 2n plus 1 is greater than let's go negative 5. Okay, so I go through and solve that. All right, so my rule is undo addition or subtraction, so I subtract 1. So I get negative 2n is greater than negative 6. Divide by negative 2, divide by negative 2, n is greater than 3. All right, so any number bigger than 3 should be a solution to this. So let's try one. Let's try an easy one. Let's try 10. Let's see if 10 is a solution. According to this, it should be because it's bigger than 3. Okay, so negative 2 times 10 plus 1 is greater than negative 5. Let's separate this here. Okay, negative 2 times 10 is negative 20. Plus 1 is greater than negative 5. Negative 19 is greater than negative 5. All right, so we see we have an issue here. It turns out, right, it's actually less than. Okay, so there's a special circumstance when we're dealing with inequalities. Okay, when we have our variable negative and we change it to a positive, so right now we're at this step and I want to change it to positive 1n. Okay, our rule is we have to flip the sign around. So when I divide by negative 2, n is now positive 1n, right? Those cancel out. So my rule is I have to flip the sign around. And that becomes positive 3. Now if we try that, we want a number less than 3. Okay, well a number less than 3 would be 0. Well, negative 2 times 0 plus 1 greater than negative 5. Negative 2 times 0 is 0 plus 1, which is 1. Oops, that should be a 5. Sorry about that. Okay, we now have a true statement. 1 is greater than negative 5. So again, very specific case of where our variable is negative, it's now positive. That's the only time we flip the sign. Okay, only time we flip the sign. So now if I want to graph that, okay, there's my number line. Okay, so I would put an open circle at 3. Since we're not including 3 in the solution, it's n is less than 3, open circle at the 3, and my number would move to the left because we want numbers less than 3. So anything along that line would be a solution. Okay, so again, just to recap, we're going to solve these the same way we would as equations. Okay, if you have like terms, combine like terms, all that kind of stuff. The only extra rule we have is when, like I said, in this particular case, where we have a negative variable, and at that last step we're going from a negative to a positive, we've got to flip that sign around. Okay, we saw an example of where if we don't get correct solutions. And then we're going to graph. Okay, again, open circle if it doesn't include the number. Okay, if we add in the equal to part, we would have to fill in the circle.